Here is the answer for day 2. Sketch 2 periods of this function. This is a cosine function. Now let's consider the general cosine function. Y equals a times the cosine of bx minus c and then plus d. In our problem, we see that a is 3. We can see that b is a 1 right here in front of the x. We can see that c is negative pi. Be careful on that. The general form says negative c. Our problem is plus pi, and so that means that the c is a negative pi. And then the d is a negative 1. Now, these different numbers figure out stuff about the curve. Of all of these values, the first one that we need to use is the value of d, because it moves our horizontal center line of our wave function. So instead of going along the x-axis as the center line, it's going to go down 1 unit. And we're going to redraw with a dashed line our new center line. The humps that we're going to draw in a bit are going to go above and below that center line. The next value we're going to use is the fact that a equals 3. So we're going to use this second. This helps us get the amplitude. The absolute value of 3 is 3. From our new center line, we're going to go up 3 units and mark that as our maximum value. That's at 2. From that new center line, go down 3 units and mark that one. That's at negative 4. The highest the humps will ever reach are positive 2, and the lowest that the humps will reach is at negative 4. The distance between our dashed center line to those marks is 3 units, given by the value of a. The next one that we're going to use is the c. So we're going to use that one third, because c gives us our horizontal shift, also called phase shift. So instead of starting our graph from the y-axis, we're going to start our graph from negative pi, which is over here. I'm going to draw a dashed line representing our new starting axis. For cosine functions that don't have any value of c, we would find a dot on the y-axis, and then we would find other dots going to the right to get a period. We're going to do the same thing, but we have first shifted left pi units to locate a new axis, and we're going to start from there when we find the dots. Now we're going to look at the value of b. So we're using this one fourth. The value of b is used to find the period. So let's figure that out over here. The formula is 2 pi divided by b. So ours is 2 pi divided by 1, which is equal to 2 pi. From our new vertical axis line, I'm going to go to the right 2 pi units. So here's pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is the same thing as 2 pi units. There's where 1 period is, stretching from here all the way over to here. That's 1 period. Now, let's find our first dot along this vertical dashed line. For a normal cosine function that doesn't have that phase shift adjustment, the dot on the y-axis is at the maximum. So for ours, the dot will be up at a height of 2. After 1 full period, you're back at a height of 2. Halfway between this spot and this spot is where the dot is at the minimum. Halfway between this mark and this mark is where you're crossing through the axis. But remember, we're crossing through our new dashed line axis, not the x-axis. And similarly, halfway between here and here is where it's crossing through the axis. So here is the curve. This is 1 period of the curve. Using the labels that were already on the axis line, we're supposed to draw 2 periods, so we need to extend the axis. 1, 2, 3, 4. This would be 3 pi. Let's also extend our dashed horizontal center line. And now find more dots. So above the 3 pi, up at a height of 2, is a dot. Halfway between pi and 3 pi, so right here at 2 pi, is where it's down at the minimum. Halfway between the pi and the 2 pi, so right here, is where it crosses that dashed center line. And then halfway between the 2 pi and the 3 pi, so right here, it's where it crosses through the center line. Now we can draw in the curve. There's 2 periods. Notice how stretched out this was, and that we barely got this to fit on the paper. That was caused by the fact that the axis was labeled before we actually had considered the different numbers involved. That's why I've made the point to you this year that you don't want to label anything on your grid paper until you've actually figured out what all of these numbers are going to do. Then you can make wiser choices when labeling all the little marks on the paper.